tonight learning about learning. So I grew up here in Birmingham, Alabama. I'm the oldest of 5 kids, and I wanted to be a teacher from day one. So my dream in life was to teach school. So I was a little girl that would lay out all my stuffed animals. I don't know if any of you did this, but I'd lay all my stuffed animals out, and I named them all, and I got my dad to take me, or my mom to take me to the parent-teacher store, and I would get a grade book, and I'd get workbooks, and then I'd photocopy them, and I'd, teach school to my little stuffed animals. And as I went to school, I would copy those pages, and I loved filling out my handouts inappropriately or incorrectly, so that I could grade all of their work. And so I had this little green grade book, and in that green grade book, you can see up here that I would name. I had lesson plans for where my kids were going to sit. And then I would coerce all the people in the neighborhood to come down to Kimberly School after they would leave school. And this was something I found from 1983 when I was testing everybody on their ability to swing, their swinging lessons. So I gave my sisters, scores and all the kids in the neighborhood. So from day one, that was my goal. I wanted to teach, I wanted to grade papers, I wanted to, change the lives of children. And so as I grew up, I ended up going to Vanderbilt for college, loved being in school there, learned a lot from books about how to teach and how people learn. And so then I started teaching school, and as I taught school, I realized, wow, gosh, people learn really differently. Like I would teach a really good lesson, or a lesson I thought I did a really good job teaching, and some kids would get it and some kids wouldn't. And why did this kid have trouble learning his multiplication facts, but this little girl didn't? And why does this little kid have trouble reading, and why does this one not? And so I became really fascinated in learning about learning. I wanted to know, okay, so we have a brain, and I had heard there was like a memory box in the brain, right? I'd seen these pictures of a file box, and I thought, okay, where is that file box? How do you get something to go into memory, stay there, and then retrieve it on a test, right? And I figured, wow, if I can figure that out, then I could be a really good teacher and help kids learn in school. So also while I was growing up, I should tell you, I'm not a great speller. And people don't believe that sometimes because I went to Vanderbilt and Harvard, but really, I'm a really bad speller. So growing up, I always wanted to be in honors English class when I was in high school. I was also not a great reader. So I did not like reading. I did not enjoy reading. I did not enjoy any type of reading, actually, to be honest. And so, but I was always forced to read books for school. But I did want to be in honors English. That was like a goal that I had. And my school would never let me into honors English because my PSAT scores were too low. I don't know if any of you ever experienced that, but my PSAT score in reading comprehension was never high enough to get me into honors English, even though I had A's in English. And so from that point, I felt like those standardized tests were really this definitive measure of my intelligence, right? I thought, okay, well, I'm a kid that works really hard. I can't spell, but I'm not really that smart, because if I was that smart, I would do really well on this test. And that was my view of if you're intelligent, you would see that on your test. And so as time went on, I did get into Vanderbilt, went there to school, then ended up going to Harvard for graduate school and loved being there. And as I was there, I learned a lot about how people learn. And so at Harvard, I still was a really bad speller. So this was the cover of my notebook. Let me show you, where I studied about how people learn and how there are variations in learning. And I was still that girl that liked to do bubble letters, right? So I loved all my little bubble letters, and I'd make my cute little notebooks. And I don't know if you can see it very closely, but this is a class on learning disabilities that I spelled disabilities incorrectly on. Pretty funny, right? And so I have a heart for people who struggle in different areas. And so what I began to study was, how do people learn? Where is memory? Where is that box? That was what I wanted to find out. And so we're going to talk a little bit tonight just about the brain. You're going to get a mini course in about 6.5 minutes on the human brain and how you learn. Because what I have learned is that learning about learning can transform the way that you do school. It can transform life. And also what I have learned is that there are so many things that we believe to be true about how we learn that are not actually true. We have had an explosion in the field of neuroscience and in education and in cognitive science. We have technology now that lets us actually peer below the surface and watch the brain at work in real time. So we grew up with all sorts of theories about how people learn, and now we can see pictures and images of what's actually happening in real time. So this is a diagram of the human brain, all right? You're looking at the brain from the side. And the brain is made up of two parts. You have two sides. If you take a fist and put them together like this, we're going to get interactive here, y'all ready? All right, so you've got a right side to your brain and a left side to your brain. Two sides of your brain are actually interconnected. Information from the right goes to the left, and information from the left goes to the right. People grew up believing that there was a theory that we believe to be true called something that we refer to as being right-brained or left-brained. All right, raise your hand if you've heard of that theory. All right, guess what? No research to support that. All right, you're not right-brained or left-brained. You have a right side to the brain, you have a left side to the brain. But that theory insinuates that you use only part of the brain when you are learning, or that you have a strength in one side of the brain over the other. Truth is, you use both sides of your brain when you're learning to do all sorts of different things. All right, so you have this right hemisphere, you have this left hemisphere, and they work together. And so when you think of the brain, let's think of it like an apple, all right? So an apple has a core structure in the center, and then you've got some meat around it, and then you've got this thin layer that's on the edge of the apple, right? The skin. All right, so the brain is similar to that, where we've got these core structures deep in the middle, and then we have this outer layer that's called the cortex. And in the image that I'm going to show you up here, we're going to look at how different parts of the brain do different things. All right, so as we go through this, we're going to start at the back of the brain. So in the back right here, take your hand and put it behind your head. This part right here, this is actually where you process visual information, all right? So when you're looking at pictures, when you're looking at the keynote slides from your professor, when you're checking out images on Instagram, when you're picking out clothes to wear for the party, you know, any visual image is going to be processed and actually stored in this part of the brain. All right, when you close your eyes and you picture something, you're daydreaming in class, even though maybe you're supposed to be taking notes, but you're daydreaming about something, or you're replaying a play from your intramural football game. All of that imagery is occurring in the back of the brain. All right, and then as we move to the side, right above your ears, you have the cortex that processes auditory information. All right, so auditory information, anything that you hear, anything that you say inside your head to yourself, language, music, you know, your Spotify playlist, when you're listening to that, it's all happening up here. You've got brain cells and they're firing and they're networking together. The teacher's lecturing in the classroom, you're listening to that lecture, and that's getting processed on the right and the left side of your brain in the temporal lobe. All right, at the top of the brain, this section is called the parietal lobe. And the parietal lobe is responsible for spatial awareness. So your ability to play Tetris, right? Take an image, make it rotate, fit into something, to pack the back of the car, to pack in a carry-on suitcase so you don't have to pay the extra baggage fees, right? Any of that ability to mentally rotate something and do something with it. The front of the brain is referred to as the frontal lobe, all right? So take your hand, put it on your forehead like this. This is your frontal lobe, all right? This part of the brain is the part that is like the CEO, or it's the conductor of the orchestra. It is basically telling the other parts of the brain what to do, when to do it, in what order to do it. It plans, it pays attention, it zones out. It is responsible for saying, don't do that, stop looking at this, to finish the math homework, pick up that pencil. I mean, it's directing and cueing the behavior that's occurring in the back of the brain. All All right, the frontal lobes are the part of the brain that you don't want to damage any part of your brain, but you really don't want to damage the frontal lobes because the frontal lobes are like the command center. And so let's think of the brain almost like an orchestra where we have different parts of the brain that do different things. And so when you're reading your science textbook, let's say we've got the horn section playing, and we've got the winds going, and we've got the piano playing, and we've got drums. And then when you're doing math problems, you've got a whole different set of instruments that are coming online together to perform a certain function. And so this front part of the brain is the one that is coordinating all of that activity. If you are zoning out in class, it's the front part of the brain that is responsible for that. All right, and this is the part of the brain also that doesn't finish developing until your late 20s. All right, 28, 29, 30. So we used to believe that you were born with a certain level of intelligence, that intelligence was pretty much fixed. Like you're born that way, that's what you got. You know, you just do the best with what you have, right? That's what I believed when I took the SAT, when I took the PSAT. But now, through all of the research from the fields of neuroscience and cognitive science, what we've learned is that intelligence is not fixed. The brain actually changes as you grow, and it changes as a result of experience. So like literally every single experience that happens in your life changes the internal architecture of the brain. I mean, that's pretty cool, right? So even when you leave this talk, your brain is going to look a little bit different on the inside than it did before you walked in the door. After a Netflix marathon, right, it's going to be different at the end of that, all right? After you go on spring break, it's going to be different, all right? The brain changes from every single experience, for good or for bad. And the cool thing about that is intelligence is not fixed because you're born with certain genetic coding, but then experience is what develops the inner networks of the brain. So if you're not great in spelling, like I wasn't great in spelling, and I had a lot of opportunity to get the right type of intervention and the right type of help when I was younger, then I could have actually strengthened that part of my brain. When we look at the brain, think of it as this orchestra of activity, all right? So when you're getting ready for your finals in May, and you're thinking about, okay, I gotta get ready to study for these tests, think of the brain as having this orchestra that is playing in different regions. So my question when I went to Harvard that I really wanted to know the answer to was, where is that memory box? Okay, like where is it physically? I kept saying like, no, I want to know like, is it here, or is it here, or is it here? And like, what do we do to put stuff in there, right? Because if you could figure that out, put all the information in, and then you have your final, and you can retrieve it when you take your test. Turns out, there's not one spot for memory. There's not a box in which memory goes into. All right? Memory is actually distributed throughout the brain. So you have billions and billions of brain cells. Average number right now, if you're kind of curious, about 86 billion if you're an adult. And you've got all those brain cells in there, and those brain cells fire and network together. And so when a certain group of those brain cells fire together, when you're learning something, like adding fractions, they are very fragile. You've created a brand new network for how to add fractions. All right? You think you get it, you understand it, you get home, you try to do your homework and add fractions, and guess what? You forgot how to do it. All right? And that's because the network is really, really fragile. The brain is designed in such a way that all of these brain cells, I mean, we're talking billions of them, the way in which they communicate is that one cell gets activated and it sends a signal all the way down that long axon. And as it comes to the end of the axon, it spits, literally, spits out neurotransmitters. And then the next cell, actually, there's a parking spot for those neurotransmitters, parks in there, and then takes in that activity and activates the next cell. Now, using a lot of really big words that I did not just use. That's how a neuroscientist would explain learning, okay? Where one cell fires and then another cell fires in response to the first cell firing. And so when you are learning something, you literally are making these connections in the brain. And when one fires, the other one starts firing, and then one fires, it fires again, and as it fires a little bit faster, that's when we know that learning has occurred. The interesting thing about the brain and how these cells are networked together is that you have to refire these cells a certain number of times in order for it to remain active in long-term memory. So we don't actually move anything into a box. What we do is actually refire the network that was created originally from the experience. So if you're sitting in class and a teacher is teaching on something about World War II, and you got this really cool new pen, and you're so into the pen, right? And then it clicks really cool, and oh man, it smells pretty neat too, and well, look at it right, and if I fiddle with it this way, and maybe I flick it over here, right? You are so into the pen. The teacher's teaching a wonderful lesson about World War II. All right, you leave, you try to do homework, you may not remember anything that was actually said about World War II, because if you are not paying attention during the learning experience, then it's not actually going to make a network. All right, what will you remember? The pen, right? You're going to have a great network for the pen. You're going to have memory in the taste part if you licked it. That would be kind of awkward. And the smell part if you smelled it. Lots of tactile memory. You're going to have memory distributed across the brain in a wonderful network about the pen. And so attention is going to dictate what gets saved into memory and what gets laid down. The cool thing about this is that when you sleep, this information that you learned during the day, or the experiences or the networks that you made during the day, guess what? They get refired over and over and over again during REM sleep. That's the rapid eye movement part of sleep. So that's actually when you're dreaming. So you get one REM cycle every 90 minutes. All right, so during that dreaming part of sleep, your brain tonight, if you get 90 minutes of sleep, is going to refire those connections over and over and over again. And that is what is going to make those connections stronger. And then tomorrow, 24 hours later, we're going to know what remains active in your long-term memory. So, all right, as we apply this to being a student, all right, I'm going to give you a few takeaway tips here, all right, that I think are really, really important to know in terms of how we can use this information from the field of neuroeducation, which is what I study. And that's the translation of cognitive neuroscience into classroom practice. And so here are your 3 top tips. Are you ready? Number 1, sleep. All right? You need sleep. All right? So fun to go out, so fun to have a great time, but sleep needs to follow learning. What you do right before you go to sleep at night, literally right before you go to sleep at night, is going to get priority in being stored in memory. So as you're studying for your test, what I want you to do is study earlier in the day, pull out your notes, review it for 5 or 10 minutes before you go to bed. It will actually help store that in long-term memory. Second thing that I want you to remember is that memory is distributed all throughout your brain. So students who encode what they're learning physically in the back, because they have visual imagery, on the side, because they talked out loud while they were studying, on the top, where motor movement is, because they recopied their notes, they physically have more places in the brain that represent that information, and they have more ability to recall it later. And the third takeaway tip is that the way something stays active in long-term memory is you have to review it over and over and over again. It doesn't have to be direct repetition, but you have to refire that network. So when teachers tell you study a little bit each night, Ed, and then like nobody ever does it, right? The reason, and I don't even know that they know why they're telling you to do that, but the scientific reason is literally 5 minutes of a review one day, not like 45 minutes, but just 5 minutes, is going to refire those networks, and then while you sleep, it's going to code it into memory, and then when it comes time to study, you're not going to have to study as much at the end. So I encourage you to dive into this field of neuroeducation if you are interested. Start learning about how you learn and how this can impact what you do as a student. And I want to encourage you that intelligence changes and our brain changes as a result of experience. So if there's something that you're not great at doing and you really want to become better at doing that, you can. And if you pick the different experiences that are going to improve those networks in your brain, literally next year at this time, you can have a very different brain than you have today. So thank you very much.